Welcome guys. So our question for today goes on. So the diagram above shows the velocity, time, graph of a vehicle. So we have the motion of a body of a vehicle, that is from time z, which is 0 up to what, to 90 seconds. So this shows the motion of a vehicle. Now let me quickly interpret the graph. So we have velocity, that is velocity against time, which is in seconds, velocity which is in what, meter per seconds. So now we are to interpret the question. Now for the first 20 seconds of the vehicle moving, we call it acceleration. That is from center 0, the first 20 seconds of the motion of the vehicle, we call it what, acceleration. That is the body accelerated uniformly, that is equal velocity with equal time interval. That is change velocity with equal time interval. So that's what we mean by what, uniform acceleration. That is the body moves with what, uniform acceleration. So this is the uniform acceleration. So then the next 30 seconds of the vehicle rather, the next, this is for the first 20 seconds. Now for the next 30 seconds, that is 30 plus 20, which is what, 50 seconds. So for the next 30 seconds of the vehicle, it maintained the same velocity of 80. So the vehicle maintained the same velocity of what, of 80. So we call this motion here, we call it uniform velocity. Then after 40 seconds, the vehicle retarded, that is decelerated. This is acceleration, and then this is what, deceleration. For how many seconds? 40 seconds. That makes it what, 90. So that is total time taken, and this is the highest velocity. So now they ask us to determine the acceleration of the car, that is the motion, this part, that is the acceleration of the car. And then we have to look for the what, retardation, which is deceleration of the car, this part here. So how do we go about our solution? So let's label our shape. So we have our this center O, let's say this is A, B, C, D, and then this is E. Now for the first 20 seconds, that is where the acceleration took place, first 20 seconds. So to calculate our acceleration, so our acceleration A will be equals to the distance covered, that is acceleration, that is the velocity of the car, of the vehicle rather, for the first 20 seconds, which is what, 80, that is the velocity of the car, of the vehicle for the first 20 seconds. That is when the acceleration took place, which is 80 divided by the time taken at that period of time, which is what, 20. So our acceleration is going to be 80 divided by 20, which is what, 4 meters per seconds square. So that is the acceleration of the vehicle. And then let's determine the retardation, that is when it was coming down back. So retardation is going to have a negative value. That is why we call it retardation, that it is decreasing. It is decreasing, retarding. That is deceleration. So to calculate the deceleration, so initially the vehicle started from a velocity of 0 and ended at the velocity of what, 80. So that's what we call acceleration. Now deceleration, the vehicle started from the height, from the velocity of 80 down to what, 0. So it's retarding backward this way. Initially it's what, accelerated, that is from 0 to 80. Now it is what, retarding. So this is acceleration, this is deceleration, negative, that it is coming down. So same pattern. So our deceleration A will be, that is the change in velocity now is retarding, so it's coming from the 80 down to what, 0. So that will be minus 80 divided by 40. So 40 into 80, that is 2. So our deceleration is minus 2 meter per second square. That is telling us that it is what negative, that the negative telling us it is retarding. So our acceleration is 4, while our deceleration is what 2. So which one has the right option? So option C. So option C is the right answer. Thank you for watching.